All right, Math 2, we got lesson 1.3.4, angles and sides of triangles. All right, so first thing we got is the triangle sum theorem. You've probably seen this before. The triangle sum theorem says the interior angles of a triangle add up to 180 degrees. So if you add up all three angles inside of a triangle, it always adds to 180 degrees, and we're going to prove it right now. Normally I do it with a flowchart proof. I'm not sure if there's going to be enough room. We'll see. Here's what I'm going to say. So I want to prove that A, B, and C, those should add up to 180 degrees. Okay, so that's my goal. So here's the first thing I'm going to say. I'm going to say that these three angles up top, these three angles right there, they make a straight line together, right? This one, and this one. So if they make a straight line together, then D, B, and E must add up to 180. So I'm going to say the measurement of angle D plus the measurement of angle B, let's use capitals, plus the measurement of angle E. Those three angles together, since they make a straight line together, should be 180. So we're just adding up the angles, and they should equal 180. What else do I know? Well, I know I've got two parallel lines, and I've got a transversal right here. And angle D and angle A from the last lesson, these are alternate interior angles. They're both on the interior, they're on different sides of the transversal, they're touching different parallel lines. So we learned on the last lesson that those two angles are congruent to each other because alternate interior angles are congruent. So this one we were kind of skipping. This was actually supposed to be 2 steps, but whatever. Our reasoning for this one is that angles forming a line add up to 180 degrees. So that was our reasoning for that one. Our next step is we're going to say that angle D and A are congruent. So the measurement of angle D is equal to the measurement of angle A because of alternate interior angles. But wait, we have more. We also have these two angles that are alternate interior angles, E and C. So we can also at the same time say that the measurement of angle E is equal to the measurement of angle C. So the reasoning behind that is those were alternate interior angles, and alternate interior angles are congruent. All right, now this is where it gets interesting. We just said that D is the same thing as A. So over here on this top equation that I wrote, instead of D, I can substitute and plug in angle A instead. Right? They're the same, so instead of D, it's okay just to replace it with A. So I'm going to write measurement of angle A instead of D. And then I'm going to put plus measurement of angle B. So I'm rewriting that top equation, but now I'm replacing some stuff. Now I can also replace over here. E is the same thing as C. So instead of E right here, I can take this and replace it into that equation. And so then I'd have plus the measurement of angle C, because that replaces E, they're equal to each other. And then finish out the equation equals 180 degrees. So what did I do there? I did what's called substitution. Guess I should have left more room, but good enough. Now what do we have? we have A plus B plus C equals 180. A, B, C, 180. Those are the three interior angles of the triangle, and they add up to 180, just like they said they did. So we have proven mathematically that that has to work. The angles inside of a triangle, the interior angles of a triangle, always add up to 180 degrees. Triangle inequality theorem. The triangle inequality theorem says that when you've got a triangle, that the sum of the two smallest sides have to be bigger than the third side. So I'm going to write that down and explain what that means. So the sum of the two smallest sides has to be bigger than the largest side. And this really makes sense. I'll just kind of draw you a picture. Let's say that I had a side of a triangle. Oh, that's really bad. Let's just say this is, I don't know, 12 centimeters long. Now let's say that I wanted to make a triangle with two more sides. Okay, so if I made one of the sides, I should have used this. Let's just use this. I'll make it actual measurements. That'd be smart. All right, so let's prove this is true here. So there's 7 centimeters. Now let's say that I had two other sides. One of those sides was 3 centimeters, and the other side was 2 centimeters. Now, according to the triangle inequality theorem, this is not possible. I can't have a triangle where I have 7 centimeters and then the two smallest sides are not, when I add them together, they're not bigger. It won't make a triangle. Here's why. 3 centimeters. If I connected 3 centimeters from this end, it would only make it to here. That would be 3 centimeters. And if I got 2 centimeters over here, that would only make it to here. These two sides can't touch because they're not bigger than 7 centimeters. So I can't make a triangle out of that because this side over here can only be somewhere along this arc right here. And then this side over here being 2 centimeters can only be along that arc. They'll never touch each other as sides. So they can't be a triangle. So these two sides have to add up to more than 7 so that the two sides can touch each other. So the smallest sides have to be more than the largest sides. Otherwise, those two sides just can't touch and you can't get a triangle out of it. That's the triangle inequality theorem. The two smallest sides have to be bigger than the third side. Otherwise, they're not going to touch. So here we've got a problem. I want to know what my third side of this triangle could be. Now let's assume that these two are my smallest sides. We'll call this side X over here. So I know that these two smallest sides have to be bigger than this side over here. So that means that this side has to be smaller than these two added together. So X has to be smaller than 8 plus 6. So I have found out that X is smaller than 14. Anything bigger than 14 and these two sides wouldn't be able to touch each other. So my third side has to be smaller than 14. But wait, what if 8 were the smallest side? 6 can't, the biggest side. I said smallest. What if 8 were the biggest side? So that's another case I have to take into account. Now, it doesn't look like it, but when we look at pictures in geometry, we never just base it off of what it looks like. We look at the numbers because sometimes the drawing isn't drawn perfectly. So what if 8 was the smallest? Gosh, I did it again. What if 8 was the biggest side? Now, if 8's the biggest side, then that means that these two sides together have to be bigger. So I'm saying that x plus 6, my two small sides, they have to be bigger than 8, the largest side. Subtract 6 from both sides, and now I found out that x has to be bigger than 2. All right, so I've got two things I have to look at. What if this is the biggest side? If it's the biggest side, then it can't be bigger than 14. It has to be smaller than 14. The second thing I looked at is, what if this was the biggest side? If that's the biggest side, then x has to be bigger than 2 in order for it to work. So if I'm looking at a number line with my solutions in it, I've got 2 over here. We can't be equal to 2. We have to be bigger than 2, so that's this direction. On the other side of the number line, I've got 14. And on this one, we can't be bigger than that one. We have to be smaller than that one. So what is the possible values for x? It's everything in between 2 and 14. Any of those numbers would work, not including 2, not including 14. It's everything in between 2 and 14. Now, the way that I want you guys to write that is to say that 2 is less than x and the x is less than 14. This just means all the numbers between 2 and 14. And those are the possible solutions of x. Now, there is a shortcut to this. You do not have to write this every single time. I don't know if you noticed it, but the two numbers added together, 8 and 6, that makes the 14 the biggest number possible. And then the two numbers subtracted from each other, see I subtracted over here, these two subtracted makes the lowest number it can be. And that's always going to happen. So the two numbers subtracted, that's the lowest number. The two numbers added, that's the biggest number. It's always going to be between the subtracted numbers and the added numbers. All right, which sets of numbers could be triangles? All right, 5, 3, and 10. So in here, the two smallest sides are 5 and 3. And over here it's 10. Now the two smallest should be bigger. But I get 8. 8 is not bigger. So this is not a triangle. Because the two smallest have to be bigger than the largest side. Otherwise, they're not going to touch, remember? All right, over here, my two smallest sides are 4 and 9. The two smallest have to be bigger than the longest side. And in this case, yes, it does work. This was not true. So that is a triangle. Because 13 is bigger than 12. This one right here, the two smallest sides are 2 and 4. It should be bigger than 5. 2 plus 4 is 6. 6 is bigger than 5, so that could be a triangle. It's a triangle. Because those two small sides can touch. Over here, I've got 3, 5, and 8. So my two smallest are 3 and 5. And they have to be bigger than 8. They are not bigger than 8. They are equal to 8. So that's not a triangle. If they are equal, here's what you've got. If you've got equal, let's say this is 8, and then this was from here to here, that's 5. That means from here to here, that would be 3. You wouldn't get a triangle out of that. You'd have these two lines directly on the biggest line. It'd just be one big straight line and not a triangle. So you can't be equal. You have to be greater than so that these two smaller sides can actually touch each other. All right, side and angle relationship. So the side and angle relationship is this. See how this 127, that's a pretty big angle, right? Well, the angle that if we follow out the angle, that 127 is making this side over here, the 9 side. That's my biggest angle, and it just so happens that's my biggest side. My smallest angle is 121. Follow it out until the endpoints here. That's my smallest side. So the smallest angle makes your smallest side. This is my medium angle, and if you follow it out over here, the medium angle makes the medium-sized side. So the side and angle relationship is that the largest angle creates the largest side. And the smallest angle makes the smallest side. Now, basically, the two sides that don't touch the angle is what it's creating. So this 127, 4 touches it, so it's not creating that side. 6 touches it, so it's not creating that side. So the 127 is creating this side over here, this 9 centimeters. So biggest angle creates the biggest side. All right, 107. In triangle ABC, the measurement of angle B is 90. Aaron says that AC must be the largest side. All right, let's draw this triangle first. So it says, I got a 90-degree angle in there. So here's my 90-degree angle. They said B was the 90-degree angle. So we're looking at triangle ABC. Now Aaron's saying side AC, that's this side over here. Aaron's saying that is my biggest side, no matter what. It's got to be. And you know what? Aaron's correct. Aaron's correct because these two other angles, angle A and angle C, they have to be smaller than 90. Because remember right at the beginning, these angles add up to 180. So if I've already got 90 degrees here, these two angles together have to add up to 90. So that means individually, they're both smaller than 90. So angle A and angle C have to be smaller than 90, meaning that AC has to be the longest side because B is the longest angle. So she's correct because angle A and angle C must be less than 90 degrees. And AC is the side formed by the biggest angle. And our biggest angle, of course, is 90 degrees here. So that has to be my biggest side. All right, last one. Just determine the minimum and maximum lengths for the third side. All right, this is pretty easy. Remember, up here, all you have to do is add them and subtract them. So the minimum would be these two numbers subtracted. So the smallest value for that side would be 19 minus 13, 6. And then DF, so DF is going to be bigger than that. And then the maximum that it can be is 13 plus 19, which would be 32. So the minimum value is 6. It can't actually be 6. It has to be bigger than 6. And then it has to be smaller than 32. So DF has to be between 6 and 32. Same thing for this one. Subtract them. We get 1. XY has to be bigger than 1. And then add them, and I get 29. So the smallest value is 1. The biggest value is 29. Remember, that can't be 1. It can't be 29. It has to be between 1 and 29. Then the last one. Now we're just using variables. So the smallest value would be A minus B. and then AC is the third side, and then it has to be smaller than the maximum value of A plus B. There you go. Finish with your notes. All right, guys, math hard. I will see you later. Bye-bye.